So if no one against the schedule, so take your time.
Okay. Uh, Thank you very much. Good afternoon, everyone. So today I will present you my research with the topic on implementation of network remote ID in the US traffic management, UTM flight monitoring and conflict detection and analysis using machine learning techniques. So my name is Nino Ruseno. My special thank you to Professor Franklin, my advisor, who give me the guidance and support during my PhD, and also to the committee members that are present here today, and also to several guests that from US and Norway, and also from IULI Indonesia that join us online. So my presentation will start with the introductions, then we'll go about the literature review, and I will explain about the methodology used in my research, then the result and discussion, and it will end with conclusions. So I want to start my presentation with a picture from the future. So many researchers believe that the application of drone or UAV will grow and attach to many parts of our life, such as delivery, construction, infrastructure inspections, disaster response, security, and also agriculture activity. With this kind of conditions, there is a need that a system that can manage and control the traffic of the UAV. So this system, we call it US traffic management, or UTM in the terminology in the USA, and U-Space in the terminology of Europe. This is the frameworks of UTM and U-Space. Both of them are quite similar. They have the US operator to control the US itself. Then it's connect to the US service supplier. They connect to other stakeholders to get the kind of services. They also connect to the flight information management that control air traffic management for the coordination. So the difference between two systems is mainly in the UTM it consists of one system because USA is only one country. In the U-Space it is European. They have several countries. Each of the system will connect each other. In managing of the US traffic, there are many challenges that many researchers mentioned in their research that would hinder the successful of the UTM system. One of them is about the performance monitoring. It is the monitoring how the flight of the UAV could meet the intended performance expectation, and also should meet the safety requirement with the separation threshold, and also could provide the high density that operator not overly conservative using airspace. Another challenges is about the communication channels. There are several options to be used in the UTM communication. One of them is the ADSB that is currently used in the managed flight, and also there are several communication channels such as 4G, Wi-Fi, Bluetooth, and also remote ID. The remote ID is a new communication established for the UAV, and also there is an option for the hybrid communication which combines several communication channels. And another challenge is about the technical conflicts that manage the safety during the flight by maintaining separation between the UAS. Based on that challenges, there are several research questions that's selected in my PhD program. The first one is about what is the most suitable communication protocol used for the current UTM operations. Then, since we hypothesize that the remote ID will be the one suitable for the UTM, the second question is how the quality of the current 4G infrastructure to support the network, to support the UTM operations. And the third research question is about how the network remote ID can be used for UTM flight monitoring and also the configuration in the US operations. Since machine learning currently is applied in many fields of research, so we try to use it as well. Then the fourth research question is how to use machine learning techniques to support UTM operations. Based on those research questions, we formalize our research objective is to analyze and the implementation of network remote ID in UTM flight monitoring and the configuration using machine learning technique based on the flight test data for small UAS operation in urban and rural areas. These are our research scope and limitations. The literature survey, we use only 5 years span. Then the network remote ID hardware and cloud service is from DroneTech, from Czech Republic. And the 4G networks using Taiwan Chunghwa network. The UTM application is developed by ourselves using Python programming, and also the machine learning technique is part of the Python programming. And the flight test that conducted is using small UAV and controlled by human pilot using remote control. Our result of the research has been published in 4 publications. The first one is about the UAS traffic management communications. We published it in the Drone journal in 2022. The second journal is about the analysis of 4G signal quality submitted to Journal of Aeronautics, Astronautics and Aviation, currently still in the review process. The third is a journal about the development of UTM monitoring system based on network remote ID. It's published in the Unmanned Systems Journal in 2022-23. And the last is a journal about the flight test analysis of UTM conflict detections, published in the Drone Journal in 2022. The first part of my research is literature review. Literature review is try to answer the first research questions. The methodology used in the literature review start from the design, conduct, analysis, and writing. So in design, we use several search terminology to search for the manuscript using the UTM communication or UAV communication, and we prepare it for 5 years span. Then we get 395 manuscripts. Then we include the inclusive criteria such as using in English and available in full text. Then we get 108 and we brief the reading to see the content. Then we get 72 manuscripts that is suitable for our review. Then we add in 2 standard documents. Then the total manuscript that we use in the literature review is 74. Then we do the analysis. Then we group it into 3 groups of communications with 5 categories, including the research application and remaining issues. Then we do the rating based on the categories and groups. We make discussion and analysis. Then the proposed architecture. These are the list of literature review 74 that used in our literature review. The grouping is ADSB-like and remote ID communications, and the category is definition, data format, technology, research application, and the remaining issues. I will explain briefly one by one of the groups. The first one is about the ADSB. So ADSB is an aviation surveillance technology that automatically broadcasts and periodically transmit the flight information that rely on the GPS, and it employs the high frequency. And ADSB message as a standard is consists of 112 bits elements to broadcast its flight information. The drawback of the ADSB is first is ADSB doesn't have the security features, so no system able to clarify the information. Then the second is about the traffic capacity conditions that could be as a result if the UAV using ADSB as well. And another drawback is the higher price of the ADSB modules compared to the price of the UAV itself. The second group of communication is the remote ID. So remote ID is the licensing framework using REST API format to broadcast information about the UAV owner and its location and its verification. So this mainly for the security. It's using there are 2 types of remote ID, which is the broadcast and the networks. the broadcast network ID using the short range radio communications, while the network remote ID using the internet cellular. Remote ID message consists of the identification of the UAS owner and their contact detail and its verification beside all the flight information. The drawback is mentioned in the research is since it is mainly purpose for the security, there are public resistance to the system. Currently, only the broadcast remote ID will be mandated in the US and USA, and not yet the network remote ID. And also since the remote ID, broadcast remote ID using the short range communication, the operate is small. The third group is the ADSB Lite system. We call it. It is a surveillance system similar to the ADSB system, but utilize alternative technology available in the market. There are two types of technology. One is the cellular-based technology, which is the 4G or 5G, and the non-cellular based technology such as XB, LoRaWAN, Wi-Fi, and also FWS. One of the research suggests that the ADSB Lite data will consist of 90 bytes to broadcast the flight information. And the drawback of the system is first about the variation in quality, because there is no of this requirement and also specification for this system, and there will be additional ground infrastructure required if this ADSB Lite is used in the UTM system. Based on our analysis and review, we propose the UTM multi-channel communication, which consists of the 3 channels. This one is the P2P, vehicle to vehicle. Then can be used for the US itself on board, and also for the ground stakeholders. Then vehicle to cloud, which can be used for the UTM application, and stakeholder to the cloud that can retrieve the flight data and use for other purpose. In our research, we try to implement only part of the system. So we use the network remote ID to channel the information from vehicle to cloud and the stakeholder to cloud, used for the real-time monitoring and the technical configuration. In my research methodology, I conducted several flight tests. So the traffic or UAV traffic is consists of the small UAV that controlled by the pilot. Each UAV equipped with the network remote ID. So the data from network remote ID will be transmitted via 4G communications to the cloud database. Then our UTM application will make the query of the data to the cloud database and process it, then deliver to the user, either observer or the UAV pilot for their operation. We develop our UTM application, and these are the process inside the UTM applications. We retrieve data from the cloud service, cloud database, then we filter the data to our area of interest. Then we add additional data calculation, especially for the conflict detections. Then we stream the result to the user, and also we save the data for further analysis. In this research, we do several point of analysis. One is about the 4G signal quality. Second is about the analysis in the UTM flight monitoring, and also we do the analysis in the UAS deconfiguration. These are a picture how the network remote ID using the 4G connectivity. So the network remote ID in the SWAS in the US is connect to the nearest tower of 4G. Then from the tower, the data will be transmitted to the cloud database. So in this arrangement, the signal of 4G become very crucial in delivering the flight data. So to evaluate the 4G signal quality, we use 3 signal parameters. First one is the call it SNR. SNR means signal to noise ratio. The second is we use the RSRP, which is the reference signal receive power from one tower actually. Then the third one is RFRQ, it means the total power signal received by the module. In the conflict detections, we introduce a new algorithms. We call it inverted teardrop shapes. The idea comes from research from Zhao et al. 2021 in the research with the title Multiple Aircraft Conflict Resolution Under Uncertainty. So in his research, he published this figure, which is the probabilistic risk map associated with the position error of intruders. So in these two figures, each of the UAV has probabilistic risk map, and we can see the area covered with the line is at a longer area in the direction of the UAV and the backside. But when they combine together, let's say this is the conflict will be detected, we can see that the front area of the UAV become crucial and as very important compared to the other side. So this condition resemble teardrop shape like this. So that's the idea come from. So however, since the teardrop movement is opposite to the normal teardrop movement, so we call it inverted teardrop. So that's the idea. So these are the figure, the shape of the two-dimensional inverted teardrop in our conflict detections. So the sizing is come from the human vision characteristic, which has 60-degree vision on the left and right of our eyes. Then from this characteristic, we can define that the edge, the sub edge has the direction of the 6R, and the rounding part will become 3R. R is actually the near collision area, which is rounded the UAV in the circle in the center. Then for the detection area is using the teardrop shape. And these are the algorithm of how the inverted teardrop conflict detection works. First, we calculate the relative distance between the drones. Then, if the distance is more than 6R, it means there will be no warning. If the distance is between 3R and 6R, we need to another definition about whether it is inside the sub edge or not, to define whether the warning will be produced. If the distance between UAV is between 3R and R, it means it is inside the warning area. Then another option is if it is inside the R, there is another type of warning, we call it warning for near collision. This is the near collision size. There are two types of how we define the sizing of the near collision. One is the fixed size. We follow the suggestion from the research Wainard et al. 2022. We use the minimum separation as the size. Another option is using the dynamic size with considering all the uncertainties as mentioned in the Rahib et al. 2021, such as GNS location accuracy, pilot characteristic, and the transmission media. These are the three-dimensional of the teardrop, inverted teardrop. So the shape is, we follow the pattern in efficient airspace where they have the layer of altitudes with the similar shape, and in the algorithms is similar to the two-dimension, but we add a consideration of the relative height to produce the conflict detection. In our research, one of the focus is about the latency and its method. Latency is defined by the time for data to travel from the source, which is the UAV, until it reaches the user. In our research, latency will be grouped into three types of latency. First is the broadcast time, the time for data from the UAV until it reach the cloud database. Another one is the query time between the cloud database into our UTM applications, and the third is processing time. The time in the UTM application until it reach the user. Why the latency is matter? Because latency could increase the uncertainty of the UAV positions. It could lead into risk of collision or accidents. At the end, it will affect the safety of the UAV operation. How to mitigate the latency is we should have a warning that the UAV is has a latency and make a prediction based on the previous data. In our research, we develop our UTM applications. This is the user interface that we see. So this is the condition when the conflict is detected. The color orange, it means this UAV detect the conflict, but this one is not yet. So our UTM application is developed as a web-based application. It's developed using the Python programming. Some modules using for this processing is NumPy, HTTP, and PyTorch. For the user interface, we use the Boki and OpenStreetMap. And since the teardrop shape is not there in our program originally, so we assemble the teardrop from the multiple circle with varying radius. And also, we do the coloring to give the warning is using the traffic light patterns. For the conflict detection is green to orange, and the near collision become from yellow to red. Beside the statistical analysis, we also apply the machine learning analysis. Machine learning is a type of artificial intelligence that focus on building the computer system to learn from the data. So how it works? We use the training data to train the machine learning algorithm to form a model based on the input data. Then we use the test data to be applied to the machine learning algorithm and also the models to make the prediction. And this prediction will be evaluated on its accuracy or fitness of the models, compared to the test data, whether it is good practical model or we need to train more. This machine learning can be used to make prediction, classify information, cluster data, reduce dimensionality, and also generate information. One of the advantage of the machine learning, it can handle huge data with complex relationships and multidimensional. That it is a bit hard to use the normal statistic and also human statistic. In our research, we use machine learning technique for 4G signal analysis and also for parameter identification in conflict detection. So two methods is used in the 4G signal analysis. One is the Gaussian process regression, based on the suggestion from research OG et al. 2032, and also using the random forest regression as suggested by Al-Farbini et al. 2022. For the parameter identifications, we use the random forest regression and classifications as suggested by Lee et al. 2022. To evaluate the machine learning technique, we use several parameters such as mean absolute error and root mean square error to evaluate its accuracy, and R-square to define the fitness of the model. In our research, we conduct the flight tests. These are the UAV used in our experiments. We conduct the experiment in 3 locations. One in front of our NFU laboratory, UAV laboratory is considered as a in the city. Yeah. Then in the Yulin HSR station is at the suburban area, and NFU agriculture campus considered a rural area. We have 3 flight test scenario. First about the 4G signal quality measurement. using the fixed wing, and we do the structured flight to evaluate the height and the speed, and also unstructured flight. Then we do the scenario for evaluation of the UTM monitoring with 2D condition to compare the different shape of conflict detections. Then the third scenario is about evaluation of the UTM monitoring with 3D conflict detections in the rural and suburban area, and with the stationary and flying included. Now we talk about the result and discussions. First is about 4D signal quality. So these are signal parameters. This is from the effect of the height. So you can see the trend is the signal is decreasing with the increase in the height, except for the RSRP, which represent the signal power from one source. It could be, the reason is could be because in 4G towers, they have the height, and the highest quality is at a certain height. And these are the effect of the speed to the 4G quality. It is decreasing and increasing in the high speed, but overall the trend is increasing. We compare the result with other research, such as from the GORIP 2021. So here they have several height in similar parameter with our considerations. However, here the trend is not very clear. Sometimes or the SNR is the middle altitude gets the highest quality, and the rest is a bit different. But in the speed effect, they have the effect that the signal is decreasing with the increase in speed. Another comparison with the research from Zulkifli et al. Measuring the RSRQ in different height. So this graph represent different height. So the result is quite similar with us. The trend is decreasing with the increase in height. Now we talk about the latency analysis in different broadcast rate. So the data is on the left side is lower broadcast rate, which is 1 Hz, and on the right side is the module with 4 Hz higher broadcast rate. So the result is in the broadcast time, the A figure, and the query time. So the latency is decreased with the increase in the broadcast rate, because higher broadcast rate, the data update at a more frequent data. Another latency analysis is for the detection algorithm. So we compare the 4 types of shape using in the detections. So we expect that the processing time will be different. So the result is in the teardrop, inverted teardrop shape, it will require slightly higher processing time. So this also in the result of the total latency. So these are the analysis of detection algorithms. We plot the distance of the UAV between UAV during the conflict detection. So the higher part is the average of the distance, the lower part is the minimum distance during the conflict detection. It shows that the data for teardrop shape normally has a higher distance compared to the circle shape. It means that the teardrop shape provides a larger buffer area in the conflict detection, that the UAV has a better chance to avoid the further conflict. These are the results from latency analysis in different locations, which is the rural and the suburban area. So this is the broadcast time. So surprisingly, suburban area has higher than the rural area. I think one of the reasons is because in the rural area, the UAV, the remote ID has a better line of sight to the tower compared to the suburban area. But in the query times, the rural area has a higher query time, which is further from the tower. So in the average of the latency time, the rural area has a higher latency than the suburban area. And also we do latency analysis in the flight condition. We compare the module on the aircraft is on the ground. So the result at the average broadcast time, the flying module has slightly higher broadcast time because the effect of the height. And also in the query time, also similar. The flying module has a higher query time. What be in the processing should be similar, but we can observe the flying is higher processing time at the average. I think one of them is because in the flying module they have more detection process. In the comparisons, we have the findings. We total all the data, then the average broadcast time is 0.45 seconds and the query time is 0.35 seconds. Considering that our cloud database in Czech Republic, it is quite fast. And the mean latency time overall is 0.94 seconds with standard deviation of 0.2 seconds. And we have the latency increase with the distance from urban area and the flight time. So in comparisons, the research from Ishihara et al. 2019 in USA with the similar system, UTM using network remote ID. The mean latency time is 1.2 seconds, but on their system they include the verification process. So that's why it's higher than our mean latency. And also we compare to the research from Abdul Malik et al. 2022. They use the 5G network to do the verification process, and they said they require only 7 millisecond latency. Now we go about the machine learning analysis. So here we plot the SNR data using two types of machine learning, Gaussian process and random forest. Here the green one is the training data to make the models. The test data is the red one that used for the prediction. Then the predicted value is the blue. So if the blue is close to the red, it means high accuracy. So here we can see in the height effect and the speed effect, the trend is quite similar. It is decrease the quality with the increase of the height and speed. And here we introduce another effect about distance. The effect is quite stable because our distance is only quite far from the tower, about 4.2 until 4.7. And here we observe one of something that there are some strong signal in certain distance. Perhaps it's come from the fact that at some point our module connect to other tower which has a slightly better signal quality. This one. So in terms of machine learning, we compare the random forest and Gaussian. We can see that random forest has better accuracy compared to the Gaussian. But you can see less red dot here than on the Gaussian. Then for the RSRP parameters, the trend is quite similar. However, in the Gaussian process here, it produces not good predictions because the predicted value is quite far from the test data. In the RSRQ, which is overall signal parameter, signal quality, the result is quite similar with the SNR. So how to evaluate? We use the performance matrices to analyze the structured flight, the data is from the structured flight. We can see the MAE and RSMB value here is quite small, so it means our accuracy is quite high. Then if we compare the Gaussian process and random forest. Random forest has a smaller MI and RSMB. It means it confirms that random forest has a better model for this case, and the R square as well close to 1 actually. It means the model is fit to the data. However, we observe minus value here. I think one of the reasons is because it produced a worse prediction as shown in the previous slide. We compare the result to another research from Turkey 2022 about the effect of the distance to the distributed power. It's decreased with the distance, but the distance is only up to 1,000 meters. Our distance is in 4 kilometers, 4,000 meters, something like that. Another comparison is with the Bejjati et al. 2022. They do the analysis in the RSRP and RSRQ. They put several machine learning and also the analytic methods. The result is the logarithmic has better result compared to other algorithms. However, if we compare the RSMB of this with our random forest is still better than this random forest. Since we have get information that the random forest is better Gaussian process algorithms, we do the predictions using the same model but use different data set for the test data. So we plot this, we have the data from the same location and the different locations, and the result is the trend is quite similar. However, at the same locations, the prediction data is more spread out than in the different locations. So this prediction actually we can use for the planning of route planning of the UAV if we considering the strength of the signal during the flight. And this is the performance analysis of the structured flight, and you can see our MA and RSMA is a bit bigger than previous one, so it means the accuracy is not as good as previous one. And the R square here is minus negative because the test database is different from the training database. And we use the machine learning also for the parameter identifications. One of them is the analysis the latency, and the results of the query time has very strong influence to the latency, because in our data our query time has a larger variation, almost 10 times to the broadcast time. So that's why the result is there. And the second analysis is using the random forest classification for the detection warning, and the most significant parameter is the processing time, almost 40+%, and then the distance and the interval time. So since the processing time, if we know processing time has effect on the detection warning, the computing power is become important in UTM. So based on our finding and analysis, we got into the conclusions. So the first is we propose the UTM multi-channel communication framework using remote ID. So we can see that with these 3 channels, we can improve availability and reliability of the data. The second is the 4G signal policy to support network remote ID. Its impact on distance, height, and speed is opposite to the signal policy. Then the third one, in the UTM flight monitoring based on network remote ID, can be used for tactical performance monitoring at anywhere and anytime, but depends on the cellular signal. And the fourth conclusion is the about inverted teardrop safe area in tactical conflict detection. It could improve the safety and the capacity of the traffic with the higher buffer on the front of the UAV compared to the other side, and with the clear flight direction. The last is machine learning technique can do to support UTM operation in analyzing complex data, predict new data, or parameter identification. So these are my last slide. I acknowledge the help and support from my friends from Indonesian Student Association and also from my colleague from UAV Laboratory. Thank you very much.
Okay, take a seat, please.
Thank you.
May I have a propose? We have one or two round question, and first come from Dr. Zhang Shichen.
Okay. My first question is, in your slides, you mentioned about that there's a drawback of ADSB. Could you show that as slides? Yes, ADSB, and if so, the drawback will be
One of them. Sorry.
yeah, and your drawback the ADSB is traffic capacity congestion and the high price. I want to question about what is the reason for traffic capacity congestion and high price, because as I know, the price will not be the issue of the ADSB module, right? Especially for the small UAV.
Okay, thank you.
And this is my first question. And second question, I have a question about your, what is the meaning of the value R squared in your 39 page slides?
Maybe I will go with you.
Okay.
Okay.
Yeah.
Okay, thank you very much. So, actually, this information traffic capacity condition, there will be, this actually come from one of the manuscript that I read, that it mentioned about, imagine if in the future all the UAV using the ADSB to broadcast its information, and also the managed flight has the ADSB receiver. So during the flight of the aircraft managed flight, when they are going into, especially in the landing and takeoff part, when the altitude is low, so normally the aircraft, the managed aircraft will have the bigger separation. However, the UAV will have the small separation, small area of the separations, and especially in the city area when there will be a lot of activity of the UAV. So this information will received by the managed flight. So it will become inside their separation area, especially when the altitude is quite low, close to the airport, when there is a lot of traffic of the UAV. That's why in one of the research it mentioned about this, the traffic capacity condition could be affect this managed aircraft flight in terms of the separation, and because there will be a warning in the aircraft that intruder is coming, but actually it is not managed flight, but it's in a UAV flight. So that is one of the drawback that mentioned in this is.
Okay, but this is the purpose, right? You let the pilot of the main aircraft to know where is the UAV. So even if it's a congestion because it's a busy area, so it's the purpose of ADSB. I don't think that's a drawback. It's just a feature of the ADSB.
Yeah, it could be something like a side effect that could it's not really maybe if in the future then the managed flight has has a differentiate between UAV and the managed flight, but currently on that research they not consider the difference between the UAV and the managed flight. So that's why in those research they mention about these drawbacks of the UAV of the ADSB.
What about high price?
Our high price is, if let's say if we consider on that time we try to purchase the ADSB modules, the small one for the UAV it's cost about 2,000 US dollars.
Dollars.
Yeah, but compared to small UAV, the price is almost the same to the price of the UAV itself. So to us, something like if it is used for the big commercial UAV, maybe it is affordable, but for the small UAV, we just consider a few hundred or $1,000, it's too costly.
Understood. Okay. And how about the R square in the page 39?
Maybe I
Yeah, maybe it's scored.
Negative value.
2,000 is not a big price for the main aircraft. Okay, well, what's mean the, I'm sorry, what's mean the
R square. R square is the formula to define the fitness of the models to the data. So if R square is 1, it means the model is fit to the data. Fit means we have several data, and let's say we have the regression. So the regression is fit to the data, it means R square will be 1. Or it also could be 0, but also in some other case it could be negative. But negative here means the data is not the model is not fit to the data, because it is related with actually the R square negative here is GP for the RSRP. So you can see from the previous slide. I don't know, sorry. Related to UTC.
So you are in the relationship or relative or?
If you see maybe this data with, you can see here
This is SNI, yeah.
SNR. The predicted value is quite matched to the data. The trend, the model is quite matched to the data. So it means this will produce the high R square. Almost.
You mean the blue line?
Blue line, the red,
match
the
to
match to the red.
To the green dot or red dot?
To the red actually. To the red, because the red is the test data. The blue is the predicted value based on the models. The models come from the training data.
So when the arming wise mean the perfect match,
Perfect
right?
match one.
Zero I can understand. What's mean the negative?
Negative means
The upside direction?
yeah, it can worse because it's related with this condition.
So let's get back to the number, please.
Number
39, yes?
Yeah. Yeah, SNR is random point is almost 0.9. But here the GP and the rest is
Minus 2 will be problem, right?
Yeah, correct. So either we need to the model is, it means we need to train the algorithm with another data to get a better fitness of the model.
Okay, did you get that?
Sorry?
Did you try to use the beta data track?
Actually, I don't have more data at that moment. I use current data. Maybe in the future, if we do another flight test, we can improve these models with different data.
Okay, I'm okay for now. Thank you.
Okay, how about we invite Zhang Hezong, Dr. to ask a question and give you the.
In your paper, you chose the out
Question.
and random forest.
Correct.
But when I use the random forest in the machine learning, the input parameter usually independent each other. But in your research, the aircraft, the speed, altitude, and distance is interaction each other. So why not? So why not use the totally connect network to find out the relationship with the SNR, RSRP, and RSRP?
You mean the connection between this?
this is a multi-in, multi-out problem.
Correct, correct.
And the input parameter have the interaction each other. So you need the random forest, the independent parameter should be the independent each other.
Actually,
So
yeah,
this is my confused.
okay.
Okay. And the page 18. The distance with the UAV tool should be have the formula.
Oh yes, we have formula actually. What
Yeah, I saw the formula in your paper.
Yeah.
But I think I have a little problem. So I will provide you the my score.
Okay, sure.
So my first problem is to return to the page 36.
From the book.
Your PPT 36. Yeah. Because the input parameter have the interaction, so I think your result have a low R value.
R value.
Yeah. So maybe you can consider later use the commutator network
Different type of.
to approach the model.
Okay. Thank you for the suggestion. But actually, I use these two machine learning is considering
Yeah.
from previous research that also use the similar machine learning for this. Maybe
I think the random forest is not for this model.
okay.
Yeah. And random forest need a decision tree. I
Yeah,
guarantee
right.
you a decision tree, so I am not sure why the result not match the test data. Yeah.
Yeah.
Actually, the future is not to decision the SMR is good or not.
Yeah.
Yeah.
But this result produce the.
Yeah. So the R value is too low.
For you.
Yeah, yeah.
Maybe yeah.
So maybe you
Yeah.
can try other model. Yeah. So when you get the SMR, ISRP, and ISRP, so finally, what you find out the result? The regional have the good 4G single quality or something.
Actually, from this.
Because I got the three parameter, I cannot get any sense from the UAV in the space regional. The single quality is good or not, or middle.
Oh, in the single, if you saw the single is using RSRP is considered the power signal from the single power. That here you can see the trend is actually decreasing, but in our test location actually quite far from the tower. So the quality is somehow between. This is considered, if we consider the 4G signal is something like it's not in the good condition, but it's still acceptable conditions about this range of the value.
Or you hope to find out the good latency time in the space area.
Yeah, we want to see the more focus. One of the focus is about the latency, but actually the latency actually relate with the 4G signal quality. So that's why we, after the latency, we look at the signal quality and the relation.
My question is okay.
Yeah, thank you. And now we invite Professor Lee.
Thank you. Issue how to get the flight direction C. Your system for flight direction.
Okay, so flight direction in our remote ID, actually the remote ID has the GPS and also accelerometer sensor in their modules. So when they broadcast the data, is including the direction.
So the flight direction is the same course angle of GPS.
Actually, the direction is they have the movement of the module. The movement of module will become the direction of the flight.
Okay, understand. The remote ID system, may you show the PowerPoint 13? Uh, 13.
Oh, 13.
Okay, this okay, the system change the system. Do you think that this is possible system? UAV to ground
Ground control station.
the ground control station by the internet to UTM. The system replace this system. Yes, it's reasonable and simple, cheap.
Correct. Actually, this one is the ADSB light from other research that show how ADSB light should be informed. But actually, in our research, actually this is the arrangement of our research. So actually from here, going into the tower of the 4G, then from the tower going into the cloud database, which is somewhere. Then use the internet from UTM into the cloud.
Yes.
So that is one.
Replace this system.
Yeah.
No need a remote ID device.
So far, yeah, I think remote ID one of the prospective communication channels that could be used in the UTM operation.
Understand.
Daniel, I will give you some suggestion and later I'll give you some question.
Okay.
So take it easy because I'm not good one. About your Chinese and English abstract, actually I think you should put ATC, UTM, VLL as keyword because you have performed all the study, very detailed. But your Chinese and English abstract should be covered those keywords. That is the first suggestion. Second, ADSB like remote ID, UAV, UAS. It seems not easy for the undergraduate student, even academic researcher to read your PhD report. So I think you need to add a chapter, abbreviation table. Okay, I think that is more easier. And I am very curious because Professor Lee had asked you about the direction, relative direction, height, and relative height. I think you should more precisely to determine what kind of parameter obtained by your drone, your flight test device. For instance, height, you are talking about one level from pressure sensor or GPS height.
Okay. In the remote ID, they have the barometric sensor.
Yes.
So the height is considered from that sensor, and they compare with the point when it started the flight.
Yes. So before you perform the flight test, you should put up your device, and that time you have a GPS signal and it running through stable, and you also have a pressure sensor, and then you press the button to start the flight test. At that time, you select at the moment the pressure such as 50 as 0, right? Understand. Because your test, you just try to present your slide 26.
Oh, I got the scenery.
Okay. Actually, your book have a similar issue. Structural flight height
Yeah.
0. For a drone,
So it means
it's impossible 0
not
with
fly
speed.
on the drone. Then we measure all this signal quality when the drone is not yet fly, something like that.
Actually, he is stuck at
Okay.
one surface.
Correct. Maybe yeah.
Oh,
It's
there's
not a flight, sorry.
almost a 0, but another 0.
Yeah. Okay. So the zero is
So-
not a fly, not fly.
Yes. So that is fundamental. You should define more precisely for this value.
Okay.
And actually, I have provided 14 questions
Oh,
for Professor Lee, so later he will hand over to you. And my second question is, all of your report discussion about the speed, north speed, east speed, small u and the small v. That is GPS speed component, right?
yes.
So, because I'm very picky, so you should define more precisely. The speed come from speed sensor or speed come from GPS. Okay, so that is ground speed or east component, ground speed or north component should be that. And second, can you open your book, page 41, your table, 2.4. This table,
Which picture? 41.
41. Zoom in, please. Yes. I think now it's good enough. Because your presentation slide, you using the word precisely drawback, but in your book, you using the SWOT analysis.
Actually, yes.
I a little agree with Professor Dr. Zhang. Not a drawback, not a threat, should be the future. Because of aviation, we concerning about safety first, not the price. So that is one kind of a future. Because ADSB should be more comprehensive. Think about it. For the isolated UTM, one day in the near future, will integrate with the ATM.
Yes.
So maybe we'll have some big or huge UAV It's a combination, not only the remote ID plus ADSB,
Yeah.
something like that. So that should be future.
Alright.
It's my opinion. It's my opinion. Okay. And page 56. We're talking about the Beidou. I think that is a retro review. You're talking about the GPS and the Beidou. I just Google and check the wiki. The Beidou now it should be 35 or 36 satellite, not the 30. You're talking about the Beidou satellite, number of satellite.
Number of
Yeah, 56. Yeah. Yeah, this area. Yeah. Yeah.
Oh, that.
Local flat, yeah.
I think.
China's Beidou system composed over 30 satellites. Now it should be more precise, 35 or 36.
Oh, the number of this.
Yeah, yeah.
Okay.
And small typo error, I will not mention again. I just give you a suggestion about your file text and the background information. You rely on Chonghua 4G network, right? And you using the SNR, you have 3 different parameters for the machine learning. But no one have the basic information about your test-free, 5 test-free. Is a 4G signal. Understand? Your test site is very close to your school, right?
One of the display is.
Yes. I think you should present that when you open your device on ground service, you just take 5 minutes, even 10 minutes to correct the background signal. You get 4G signal, it's a signal strength, SNR, something like that.
Wow.
Otherwise, your result also present about 10 dB decay. I think that all your result very similar. Page 27. Sorry, PowerPoint, 27. Okay. So you 10 dB, right?
Yes.
It's a 10 dB. It's a 10 dB. And you have a two slide comparison of 4G signal result of different researchers. So I just wondering for your test free for your drone, it's possible to mention when your device on ground service, your signal should be here or here, right? And with this,
The line.
yes.
So the zero mean height is actually this.
Yes.
So the average is around.
So such as your baseline, your baseline should be here. So more easier for reader to understanding your chart. Yeah. Because higher means better signal, better research result, right?
Better reception.
Yes. And same page.
SQL.
You can see this point. Those 3 points. And here should be have another point. What do you mean for the block circle?
Right. Or the result is actually is an outlier in
Oh, okay.
statistical-
Okay.
In statistical terminology,
Okay,
it's
yeah.
defined outlier.
Yeah, okay, understand. So now you present, now I understand. And I think my last two questions is about R square, negative value.
Same question.
Yes. 38
Yes.
and 42. RSRP always negative and greater than -2. How come? How come?
Actually,
Please present your PowerPoint page.
I think this is
38 and 42.
this one.
Yeah. Because I have checked your question, your RSRP and two value, right? And,
In normal statistics, actually R square normally between 0 and 1.
yes.
1 is close to the
Advantage.
right? 0 is 1. But I also searching in the internet, what happens if the R square is negative? Is it there is a reason behind or something like that? So when I search this information, actually the R square is used actually in the linear relation in the statistics, more on the linear side. So it means if the data is far from the linear characteristics, it means the R square will not has a value as the normal between 0 and 1. So that is the idea. That is the explanation that I get. That's why then I realized why is minus here. Then when we look at our data, actually, this is the data that produce R square minus 2. This is the Gaussian inner RSRP data. So because the training data produce the model. Then the models, when we put the test data input as to the models, they produce the predicted value. The predicted value is the one as a result from the model. So as here, the predicted value is very far from the test data. So that it means the models produce not very, but it's not in the linear characteristics of the statistics. That's why
My point is structural fry, RSRP, GP. Previous slide, within the previous slide, please.
the previous one.
Yeah, very small, very small. That is very small. Yes. I think R square about 0.9. That is good result. That is acceptable. And this you should try to explain. It means this RSRP for structural fry, GP method is not a good one for machine learning, right? Because you also have mentioned all your data set 80% for training, 20% for test.
Yes, correct.
So now it's impossible for us, for myself, to ask you to take a more flight test. I think it is fundamental definition problem. So you just try to explain. For some condition, RSRP GP method is not fit for structural flight. I think maybe good enough for this study. And we're talking about, let's continue talking about the unstructured flight test. 42, I think it's 42. Yeah. So that's trouble. That's trouble. Because I don't know your machine learning is any kind variable of new parameter you can put into your machine learning code. Try to improve to have one or two signal become positive and R square greater than 0.6, even 0.8. Because typically for the CFD communication or file test, we always to trigger the good result using the R square, meaning for 0.8, 0.9, something like that. Yeah.
Okay. Actually, I use the R square here because previously in the structured slide I put this parameter, so I also use in this. But what I want to see here and I want to show here is actually this data plotted here is use the C model as before, but the data that train the model is different with the test data using here. So something like the training data is come from the test flight in the NFU agriculture center. But in the different location here, actually the data is come from the test data is used from the flight test in the near HSR station. So it means two different locations.
Yes.
I just tried whether this model, if I use model from this flight test, should fit to this data, because I assume it will use this, has a similar characteristic, but of course different distances, speed and height from the distance. But it is shown that with kind of arrangement, actually the accuracy is not very good, because you can see that MIA analysis is bigger than the previous one, and also what we find out is the R square become negative. Then I also searching what the explanation of this, and also one of them is because the data set is different from the training data set. Perhaps if we include the data from the different location into the training data, so the result will be improved. The model will be improved because they consider another location to form the model. I think so. The models actually, if we want to have very good prediction for, let's say, all regions, all distance, we need to have all the training data from those regions. Then at the end, the model will have a better result.
I think all the weaker point for your research is unstructured flight machine learning results. So I think you should discuss with Professor Lin how to explain those data. For me, I do not have this kind of knowledge to explain the unstructured flight. Just last comment for your recommendation. You should propose some study area for remote ID for your group, for Taiwan and for your country. I think that you have created a very strong team, and you stand at a good point for the remote ID, such as ICAO, such as FAA, have this kind of proposal. But I'm wondering in the near future have someone to follow in and extend this kind of research. We try to have a more comprehensive how the UTM integrate from small group isolated areas, such as 30 drone fly together and then become 500 and one day integrate with ATM. Which is proposed to have this kind of cooperation project or idea right into your report. I think that now is happening. So that's all my point. Thank you.
Okay, so we have a very fruitful discussion. I think the Professor Neno have do a lot of research, and this area actually is quite new. Consider on the other things, because most of those things is still under development, not really have any real side really working on based on those information. But one thing is like Professor Dr. Guan's talking, those results can be extended to considering next phase, the near future, how we can do that in the real world. That's one part of it. The other part is about the machine learning, because we really have some point. I think that all those raised very good point. I expect you can make that a more complete work in a few months. And even you are not in person next year, I think that will be very good either for the research itself or for your personal to make that as a complete result or like a milestone things to do that. Thank you.
Okay, thank you.
Thank you.
Need to clear
Yeah.
only